In this video, we're going to discuss equivalent sources. What we mean by that is, suppose we have some arbitrary circuit. It's powered by a voltage source and a resistor in series. Well, we can replace that power source by a current source in parallel with a resistance. So actually, I need to fix that. That's what that should look like. Moreover, the current for the current source is Is, but it has to be Vs over R in order for the two sources to be equivalent. That is, they need to supply the same same current, or VAB, to the arbitrary circuit. So to show how this works, we're going to use two extreme cases for our arbitrary circuit. The first will be R equals infinity, which is an open circuit, and then an R equals 0 case, which is a short circuit. So let's start with an open circuit load. We have the voltage source on the left, and we have the open circuit attached to it. If we analyze this voltage source circuit, we know that the current here has to be 0. It can't flow. And because of Ohm's law, that current has a V that's polarized like this, but that V has to be 0 because the current is 0. So if we did Kirchhoff's voltage law using a loop going from B back to B, well, we have a negative Vs voltage drop going from V across and up the voltage source, then a 0 volt, and then VOC as the voltage drop going from A to B. Those have to sum to 0, which will lead us to VOC, open circuit voltage, is Vs. So we want the other circuit to have these same parameters. So it's obvious that the current is 0, and in order for this VOC to be Vs, well, we need to get the right Is. So we can see here that the current is 0 here, so it has to be Is, and that means that we get a voltage here, which is the same as VOC, right? Because VOC is defined for these two nodes. And VOC, well, by Ohm's law, this is ISR. This tells us then that we need Is to be Vs over R. And this agrees with the condition we gave you up here, the Vs over R, for the equivalency of those two sources. So we were able to design Is using an open circuit load. Now let's look at the short circuit load. This will help us confirm that the circuits behave the same way in the two limits, right? So we designed in the R equals infinity case for the two circuits to be the same. We'll see that they're the same in the R equals 0 case. That is, our arbitrary circuit has 0 resistance. It's a short circuit. So then we should be convinced that they behave the same for arbitrary R, an arbitrary circuit from A to B. Okay, so by design, this is going to be Vs over R. Starting with the voltage source circuit, we know there's some Is here. We know that we have the VOC is 0. Same thing here. Now this Is, we recognize there are really just two nodes, right? There's 1 and 2. That means that this node is higher than that node by Vs, right, because of the battery voltage source. So this Is then is Vs over R. Well, you can look at the other circuit here. We can see that this current has to be 0 because of the short circuit. All the current is going to go this way, it's Is, but we already know by design that it's Vs over R. So we're seeing that the two currents in the two circuits are the same through our load, which is in this case a short circuit. So we see that in the two extreme limits, the circuits give the same current and voltage to our load, which was an open circuit in one case or a short circuit in the other case. So we should expect that they will treat any arbitrary load the same. The two circuits are in fact equivalent. One thing I need to point out is that you have to pay attention to the signs and the directions. If we have a Vs like this, we can recognize that this is the high side and this is the low side. Again, recalling that the current here is 0, so this has to be 0 volts. So this is the low side. So it's actually the same voltage at those two connections. So it's really like one node. But in order to get this same behavior with a current source, we have to turn our current source the other way. In this case, we have the current flow this way. So that means that this is the plus side, that's the minus side. So this is the high side, this is the low side. And an equivalent to this is to point the current in the other direction, but now we use a minus IS rather than the positive IS. This is equivalent. The last thing we could do is reorient our voltage source, but give it a negative value, negative Vs. And so all that to say, just pay attention to the signs and directions. It's easy to get it wrong. I hope that was helpful in understanding source transformations, and I hope it gets you started in working with these. Remember to like the video, subscribe to the channel, leave a comment below, and have a great day.